Hi everyone, in this video we're looking at inverse normal problems, and to start off with we'll look at this example here where x has a normal distribution with a mean of 14, so we'll draw that in, mean of 14 and a standard deviation of 5, and the probability that x is less than k is 0.35, so we've got some value here k, and we know that that probability of being less than that is 0.3512. So hopefully it becomes apparent to you why this is an inverse problem, because usually we have this value and we're looking for the probability. In this case we have the probability and we're looking for the value. Okay, so we go to our calculator for this and into our stats mode, distribution, normal, and this time we choose inverse normal, which is F3, and my calculator has these options left, right and centre. I'm not quite sure if yours do, but hopefully they do. So our tail, as you can see here, is to the left, and so that's the tail that we're going to choose. Our area is 0.3512, our standard deviation is 5, and our mean is 14, and there's our inverse normal value, so 12.09 if we're rounding to 2 dp. So in this case k equals 12.09. Sometimes we do have a situation where we're not looking for this value, we might be looking for the mean or the standard deviation, and in that case we have to refer to the formula z equals x minus mu over sigma, but all other inverse problems you can do on your calculator. Let's quickly look at this one, so I'll just give you a chance to pause here and read it. Okay, so we have Natalie who bikes to and from her grandma's house with a mean time of 25 minutes and a standard deviation of 4 minutes, and there's a 90% probability that she'll get to her grandma's house before 4 p.m. So that means that if we're putting this stuff on our diagram, our mean travel time is 25, and before 4 p.m. that area there is 90. And so the question is asking when does she leave school? So applying an inverse problem here, we've got our tail left, area 0.9, standard deviation of 4 and mean of 25, and that gives us 30.12. So in other words, the cut-off travel time for her to get to her grandmother's on time is, or by 4 o'clock, is 30.12. So that means that her school would finish 30.12 minutes before 4 p.m. So that means that, roughly speaking, her school finishes at around 3:30. So we can write that in as our answer. And yeah, so that's how we do a contextual problem for inverse probability. So with your calculator it makes it pretty straightforward, but just remember that you do have this formula for cases where your calculator can't do it, and I've got a few exercises there for you to work through. Thank you.